Hello friends, welcome to VK Lectures. In this lecture, we will be discussing about special integrals.
Now this is integrals that involves the Dirac delta function. So integrals involving Dirac's delta function. That's generally given by delta of x. Now few integrals are integral from minus infinity to plus infinity, delta of x dx. This is equal to 1. Now then delta of x. What is delta of x? Delta of x is first derivative of the function f of x, where f of x is step function. Unit step function. Okay, now then we have integral from a to b f of x times delta of x minus c. This is some value c, which is equal to there are two values, either it will be f of c function at x equal to c or 0. Now these two conditions are applicable. This is when a less than or equal to c less than or equal to b. That means c lies between a and b. Okay, in the interval a to b, c should be in between a and b. If it is outside or else otherwise case, it is 0. That means if the value of the c is outside, then this particular integral will go to 0. Now fourth, it's a delta of minus x as delta of x. This is indicating that delta function is an even function. Now the fifth one, delta of ax, some constant a, it's equal to 1 by mod of a into delta of x. Delta of x square minus a square is equal to 1 divided by 2 times a into delta of x plus a plus delta of x minus a. Point of the integral is integral involving the derivative of delta of x. Example, integral f of x into delta dash of x. Delta dash indicates delta dash of x is d by dx of delta of x. So f of x into delta dash of x dx is equal to minus 1 times integral first derivative of the function f of x, the derivative shift to the first function, into delta of x dx. Similarly, integral f of x delta double dash of x dx equal to minus 1 squared into integral second derivative of the function f of x into delta of x. Similarly, you can also write integral, let's write for in general, f of x into nth derivative of the Dirac delta function dx equal to minus 1 to the power n into integral. So this is we cannot write in general like this. This is minus 1 into f dash of x delta of n minus 1 of x. Now what is this is very important. For some function we may not be able to write as it is. Okay. So this is the key formula. So it's integral f of x into delta n of x dx equal to minus 1 integral f dash of x. So the first derivative goes here, other remaining is still with the Dirac delta function f into f of x dx. Okay. So yes, that's it. Now example we can take the integral from minus infinity to plus infinity e to the power I k x into delta dash of x dx is equal to minus 1 into integral first derivative of the function e to the power I k x into delta of x dx. So that's equal to minus 1 into derivative of e to the power ikx is e to the power ikx into ik. So ik has come out, integral same from minus infinity to plus infinity e to the power ikx into delta of x. Now delta of x at here the center is 0, so put x equal to 0 to this function. E to the power 0 is 1, so that's equal to minus ik. Now why this is like this integral can be can be written as e to the power ikx into delta of x minus c. C is 0, so x into dx. Now this is the function f and this is the Dirac delta function. Now the center goes to 0, x equal to 0 here. So that's why we have like this e to the power ik. As a question, integral from minus infinity to plus infinity e to the power ikx into alpha into delta of x beta into delta dash of x plus gamma into delta double dash of x. So this can be done separately. Integral minus infinity to plus infinity e to the power ikx into alpha into delta of x plus integral from minus infinity to plus infinity beta times e to the power ikx into delta dash of x, this dx plus gamma times integral minus infinity to plus infinity e to the power ikx into delta double dash of x dx. Now this gives us alpha, this delta of x goes here, so alpha that becomes 1, so into 1 plus beta into delta dash, so e to the power ik, so I minus 1 into ik plus gamma into minus 1 whole square into delta double dash ik, so ik squared, so that's equal to alpha plus minus beta ik minus I beta k minus ik means minus square, so minus 1 so minus gamma k squared. Then integral x times delta dash of x is equal to minus 1 times integral delta of x dx. Okay, now which means when you take the integral as common, and you can write x into delta dash of x will be equal to minus delta of x, right? So this is, if you can extend, this will become integral x to the power n, and nth derivative of this delta, that is delta n of x dx, will be equal to, it starts from minus 1, integral x to the power n minus 1, and x to the power n, first its first derivative, dash represent first derivative, into delta of n minus 1, that means n minus 1th derivative of delta of x. Yes. So it continues. So we have here first derivative now, so that will be equal to n x to the power n minus 1, right? So that will be equal to minus 1 integral n x to the power n minus 1 into delta n minus 1 of x dx, and this n you can bring it out, so minus n integral, this is x to the power n minus 1 delta n minus 1, so this will become x to the power n minus 1 its derivative and delta n minus 1, so this will become delta n minus 2 of x dx with a minus sign, minus 1, because each time you have to, each time when you bring do this operation, minus 1 will come out, so that will become now its derivative is minus 1 to the power 2 n into n minus 1 integral, this becomes x to the power n minus 2 delta of n minus 2 of x, that minus 1 we already have taken into account. So this continues. So what happens in the end, what you are going to get is x to the power n delta n of x, that is this one, x to the power n delta n of x will be minus 1 whole to the power n, this n minus 1 n minus 2 will go up to n, right, 1, so this will become n factorial into delta of x. So whenever you have x to the power n delta n of x in the integral, you can include minus 1 to the power n factorial into delta of x. So shifting there, so integral x times f of x, so this is in the bracket, x times f of x into delta dash of x dx. So now as earlier we had the formula that x into delta dash of x equal to x dash into minus 1 into delta of x, right? So this is first derivative of the whatever function we have here, right? So this becomes minus 1 into x into f of x. So this one with an the first derivative into delta of x. Okay, now this is uv derivative of uv, so u into derivative of v plus derivative of u into v, right? So that becomes minus 1 integral x into f dash of x delta of x plus integral f of x into first derivative of x into delta of x, right? So this minus will be common for both. Fine. Now this x into f this x into f dash of x into delta of x. So if this limit is lying in between x, so this will become 0, right? The first term will become 0. This is because delta of x, so x minus 0. Then if you put x minus 0 here, x value will become 0 and the entire integral goes to 0. So in the end only the second term will remain, that is minus 1 into integral f of x into delta of x dx. Right. So what is the conclusion? Integral x into f of x times delta dash of x is equal to minus integral f of x into delta of x. Delta of f of x. Delta of f of x, that means delta of the function, is equal to sum over I delta of x minus xi, delta of x minus xi divided by f dash of xi. Now xi is the solution of the equation or solution of the function f of x. Example, delta of x square minus a square, that is equal to sum over I delta of x minus xi divided by f dash of xi. This is magnitude, okay? This is now when I write x square minus a squared equal to 0, this is the function. So how will I find out the solution to this function? Solution to the function is given by x square minus a square equal to 0, which means x equal to plus or minus a. So now the next thing is I want to find out, this is f of x. So f dash of x will be equal to 2x. Okay, so f dash of x at x equal to, now I want to put plus a, which will be equal to 2 times a. Now f dash of x at x equal to minus a will be equal to minus 2a. I have found the first derivative of the function at x equal to a and x equal to minus a. Now I want to apply the formula, that is the delta of x square minus a square equal to delta of x minus, my first solution is plus a, so x minus a divided by f dash of a, that is 2a, plus delta of x minus, second is minus a, so minus a divided by 2 times a minus, but the magnitude will become 2a, so that's equal to delta of x minus a by 2a plus delta of x plus a by 2a. So this is the function delta of f of x, if it is x square minus a square. The delta of x square plus 3x plus 2, this we can write it as delta of x plus 1 into x plus 2, delta of x plus 1 into x plus 2. Okay. Now so there are two solutions, x equal to 1, minus 1, and x equal to minus 2. So now what we can do is, you can find the f dash of x will be equal to 2x plus 3. Now f dash of x at x equal to minus 1 will be equal to 1. Now f dash at x equal to minus 2 is minus 1. I hope that's fine. Yeah. Now we have this delta of f of x, you can write it as delta of x plus 1 divided by 1, right? So it's my 1 plus delta of x plus 2 by again 1. Is that okay? So this becomes integral minus 2 to 2 delta of x plus 1 by 1 plus minus 2 to 2, this is dx at delta of x plus 2 by 1 dx. So delta of x integral, this will be equal to 1 if this lies, so x minus 1, so minus 1 is lying between minus 2 and 1, so that's equal to 1. Sorry, that is minus 1, and here x minus 2, so minus 2 lies between minus 2 and 2, so that will be again minus 2, so that's equal to total, this is plus. So delta of sin x. So we need to find out the factors or the solution to this sin x, right? So delta of sin x. So I need sin x equal to 0. So what are the values of x I can have? 0, pi, 2 pi, 3 pi, etc. Right? So delta of sin x I can write as delta of x minus 0, that is the first solution, plus delta of x minus pi plus delta of x minus 2 pi plus delta of x minus 3 pi, etc. Now function is sin x, f is equal to sin x, and f dash is equal to cos x. Now I need f dash at x equal to 0 equal to 1, then f dash at pi equal to minus 1, f dash at 2 pi is 1, f dash at 3 pi equal to minus 1, right? So according to the formula we can write delta of x minus the solution 0 divided by f of x magnitude, so 1 plus delta of x minus pi by 1 plus delta of x minus 2 pi by 1 plus delta of x minus 3 pi by 1, because these are all magnitude of this first derivative. Okay, now what we can do is e to the power minus x as the this one. You can write integral 0 to infinity e to the power minus x into delta of x minus 0 plus delta of x minus pi plus delta of x minus 2 pi, it goes on, right, dx. Now I need to check whether this 0 is lying between 0 and infinity. Yes, so this will become x, go to here, so e to the power 0 minus 0, just right for understanding purpose. So e to the power minus pi plus e to the power minus 2 pi plus e to the power minus 3 pi. So this is the integral value. Now this is sum of all geometric progression with e to the power 0, 1 as the a value, a equal to 1. The common ratio r is equal to e to the power minus pi, right? So the sum of all gp's is equal to a divided by 1 minus r, 1 minus r if r is less than 1. So check whether r is less than 1. Yes, e to the power minus pi, so it's less than 1. So we will write a is 1 by e to the power minus pi. So integral f of x into delta of x minus y dx is equal to f of y, and integral f of y into delta of x minus y dy equal to f of x. This there is no change in the second term, delta of x minus y and delta of y minus x. So you might be thinking delta of y minus x, because delta of x minus y is same as delta of y minus x, because delta is an even function. Now just for clarity purpose, integral minus 1 to 1 dy integral pi by 2 to minus pi by 2 to pi by 2 dx into delta of sine 2x divided by delta sine 2x into delta of x minus y. So here we need function x as a function of x. So delta of x minus y is here. So our function is this one, right? So f of y will be equal to delta of sine 2x, right? So integral minus 1 to 1 dy so this dy and this entire term will become f of y. So delta of sine 2y, yeah, dy we need not write. So this becomes delta of sine 2y dy, right? So we need sine 2y equal to 0. We need to find out the function solution. So 2y equal to 0. So 2y equal to 0, pi, 2 pi, 3 pi, etc. And y is equal to 0, pi by 2, pi, 3 pi by 2, etc. Right. Now and cos of the function 2y is equal to 1 and minus, so it will be always wait a minute, sine 2y derivative is cos 2y into 2 so 0, so that will be equal to 2. So sine 2y, okay, so this becomes integral minus 1 to 1 delta of y minus 0 dy divided by 2. Now y, it stopped at y equal to 0. The next term is pi by 2, which will be greater than 1. That's why it's not there. So delta of y minus 0, that is 1. So 1 by 2. So here we'll start with finding the roots. Cos x equal to 0 implies x equal to pi by 2 starts with pi by 2, 3 pi by 2, 5 pi by 2, etc. Okay. Now then we can write delta of cos x equal to delta of x minus pi by 2 plus delta of x minus 3 pi by 2 plus etc. Alright. Now bringing, so we have this term defined. Now integral from 0 to infinity, let me write this e to the power, and also we will write the function f is equal to cos x, f dash is equal to sin x with the minus sign, and f dash at the solutions, all solution magnitude will be equal to 1. Right. Yeah. So now the integral 0 to infinity delta of cos x e to the power minus x dx is equal to, we will start writing with e to the power minus pi by 2 plus e to the power minus 3 pi by 2 plus e to the power minus 5 pi by 2 etc. Okay, now I am writing e to the power minus pi by 2 as common, and 1 plus e to the power minus pi plus e to the power minus 2 pi etc. Now this becomes the GP, so we will write e to the power minus pi by 2 into GP, the first term is 1 minus e to the power minus pi. Correct. And now what you can do is, just multiply it by e to the power minus pi by 2 and 1 minus e to the power minus pi. So pi by 2. Now you can again take plus pi by 2 outside. Sorry, this is not pi by 2, this is pi. So e to the power minus pi by 2 divided by this, let's e to the power minus pi by 2 times 1 divided by this one, I can write it as e to the power minus pi by 2 times e to the power pi by 2 minus e to the power minus pi by 2. Correct. And these two terms will get going. Fine. Now this term is 2 sine hyperbolic x, so that is 1 divided by 2 sine hyperbolic pi by 2. So the option is